In this video, we will try to see how to perform customization in LlamaIndex. So we'll try to cover a lot of scenarios under customization. So we'll start with a very basic LlamaIndex scenario, and then we'll go over multiple scenarios one by one. So let's start with scenario number 1. In scenario 1, we will write a very basic LlamaIndex application. And before writing the application, we have to install all these packages. So one package you can see it's a main LlamaIndex one. So we can go to terminal and then you can type pip install LlamaIndex. As soon as this command ends, it will install all the packages which is required to run LlamaIndex on your local machine. And you can see in my scenario the requirement is already satisfied. If you already have LlamaIndex and you want to upgrade it to the latest version of LlamaIndex, then for that you can just write pip install -upgrade LlamaIndex command and it will upgrade it to latest version of LlamaIndex. And if you want to see which version of LlamaIndex is installed on your machine, then you can also try this command pip show LlamaIndex, and it will show you what version you have currently, and you can compare it with the current version of LlamaIndex by visiting to LlamaIndex documentation. So this will cover the basic LlamaIndex setup on your machine. So let's go to our basic application first. In the first application, we are just trying to read file from our data folder. You can see we do have a data folder over here, and under this we do have sample.txt file, and this file has around 300 of lines, and we will use this file in our demo. In this application, the first step what you need to do is reading the data from this data folder and load that data. We can do it using the simple directory reader. There are a lot of options under simple directory reader when you are passing data. So this would be passed under input direct, not just one file. You can go ahead and place multiple files over here, and then it will try to read all those files in one go without specifying the file name. The first line will load the data and create a document object, and after that we have to create an index on this particular document object. So we are going to use vector store index, and you can see this simple directory reader and vector store index is coming from this llamaindex.core, and then you just have to import it to use it. So once your index is created, we are going to use this index to perform our query operation. So in this 4 to 5 lines code, you can write your first LlamaIndex application, and then you can use it to query your document. Here you can see I'm just asking what did author do growing up, and then I'm just printing a response over here. So this is going to be scenario number 1. So let's go to scenario 2. Scenario 2 talks about a scenario or situation where we cannot parse our document in one go, because all LLM models comes with a certain number of tokens and we cannot breach it. So the idea is not to parse that whole document in one go, but parse it into smaller chunks. So how can we do that in LlamaIndex? So we can go to this method, and for that you just need to define a chunk size over here. You can see I am using a settings. This settings is coming from again llamaindex.core, and this setting would help you to define chunk size as a global parameter. So once you define the chunk size, it is going to be used across all your application. Here we have set up the chunk size as a 512. After that, loading the data and creating documents is going to be same. And while creating index, we have to pass some additional parameters. So here you can see in the first program, we were just passing a document. But here with the document, we have to pass the transformation also. If you go to this from documents method, you can see here we do have a transformation also. So earlier we were just passing a documents, but now we have to pass a transformation. And under this transformation, we can pass this sentence splitter. And in the sentence splitter, you can pass the chunk size. In our case, we are passing the chunk size as 512. So we can pass it over here. And then I am also passing another parameter over here, which is chunk overlap. So this chunk overlap is also getting defined over here. So once this is done, the rest of the things are going to be same. You have to create your query engine as it is, and then you can use it to pass your queries. This concludes our scenario 2. In scenario 3, we want to persist the index and then use it repeatedly without loading index again and again. So let me go to this scenario 3. As you can see in the first program, we were creating this index, and this index is being created in memory. So every time when we are running this code, we have to load the data, have to create the index, and then use that index for our query. But we can also persist this index. So here you can see we have loaded the data, we have passed the document, created the index, and as soon as the index is created, we can persist it over here. Once you persist the index, it will create a storage on your local machine. So you can see after executing this command, this kind of storage folder is going to be created on your local automatically, and then it will have all the data like doc store JSON, index store JSON, graph store JSON. So this file will be getting created automatically. You can go ahead this file and this will store all the embedding, all the indexes for your record. So because here we have passed the data of sample.txt file, so all the embedding doc store indexes are going to be created based on the data what we are passing in sample.txt. Now once your storage is created, you can use this storage without loading the document again and again until there are some changes are in the document. So every time you don't have to run this code again and again, you can keep this part in one method which would help you to load the data and create the index. Then for querying, you can define these particular code into some different methods, and that method you can pass it to user for calling. Here actually I have just put it everything into one go for simplification, but the ideal way of using it to split out into different methods. One method is going to be just to load the data and create the index, and another method is going to be just to query the index. Because once the index is persisted, here you can see like I'm again referring to my storage where all my indexes would be stored, and then I'm using it for the query. Here because my index has been defined and stored, so I'm going back to this storage location. I'm retrieving the index what I have created and then using that index to query our query engine. So here I'm not directly taking the index from here and using it for query. I have to store it, then have to retrieve the index, and then have to use it for query. So how to retrieve the index? So here we use this storage context dot from default, and you can see this storage context also comes from llamaindex.core, and then we are utilizing other method which is load index from storage. So once you have these two methods, you can retrieve your index, and then after that, once the index is retrieved, you can use it to query your document and get the response. This is what scenario 3 talks about. Let's go to our scenario number 4, and in scenario number 4, what we are saying, instead of using the default vector store, we want to use some external databases for vector store. So we do have multiple options over there as of now. In this particular program, we are going to use Chroma because this is easier to install and easier to demo. You can have a multiple vector stores, and if you want to work with Chroma, then the packages that you need to install is pip install ChromaDB, and then you have to install another package which is LlamaIndex version of Chroma. So once you have these two packages installed, then we can go to this method. First thing what you need to do is create a client of Chroma, so that we can do it using ChromaDB.persistent client. And once you have that client created, then we have to create a collection. So under this collection only, we are going to store our embeddings. Collection, you can consider it as a table which would hold all your data. To create a collection, we are going to use the client that we have defined earlier. So this is going to be client.createCollection, and collection name I have given as a quick start over here. So this would create your collection, and now you can use the Chroma vector store which we have got it from LlamaIndex, and then you can use it to pass our collection which you have created at this step. So this Chroma vector store that you can see, it's coming from LlamaIndex vector store.chroma, and the ChromaDB client which we have created is using official ChromaDB package which is going to be ChromaDB. Now actually we have created our vector store by passing the Chroma collection. Once you have your vector store created, we have to make it our main vector store instead of using a default one. We are flipping that using this vector store into storage context. So this is storage context, as you can see, it's a container for containing all kind of data. So instead of using default vector store, we are going to pass this particular vector store. Now you just have to load the document as it is. After that, you are going to create the indexes. Another variable of from documents we are using over here, which is going to be storage context. And you can see the storage context here we are passing what we have created from our Chroma. And now we are flipping the default storage context with this particular storage context which we have built on top of Chroma vector store. Now once this is done, you can just go ahead and use the same methods which we have used earlier. You can create a query engine and then you can use it to perform query. And this is scenario number 4. Now we will go to scenario number 5, and which is like you want to retrieve more context while performing queries. So let's go to this particular method now. Here you can see again we are loading the document, creating the index. The only difference you could see over here, when we are going to query the document, so instead of going with the default value, we are modifying this particular parameter. So by default, the similarity top k parameter retrieves only 2 similar document, but now because we want to get more context in the output, so instead of passing 2 nodes, we are going to pass 5 nodes. This is how actually you can retrieve more context when you are going to query any particular document using LlamaIndex. The rest of the steps steps are going to be same. You can perform the query and get the response. Now let's go to scenario number 6. There could be a situation where you do not want to use the default GPT 3.5 turbo model and you want to change this to GPT-4 or some other model. So how can you do that? So let's go to this method now. And one thing you can notice, like in all our queries, we haven't defined anywhere our OpenAI model, because by default it uses GPT 3.5 turbo. But now I want to change certain parameter of that model, or you can also change that model altogether. And for that you have to use OpenAI. And here you can see there are certain parameters: model temperature, max tokens, max retries, timeout, and all those things. So all these parameters you can go ahead and change it if you want. I want to try GPT-4 model instead of GPT 3.5. So I am just using this OpenAI, and this OpenAI, you can see it's coming from llamaindex.llms.openai import OpenAI. And now actually once you have defined your LLM, so I'm just taking this LLM and then passing it over here and then using this query engine to perform our query. So now instead of using GPT 3.5 turbo, it's going to leverage GPT-4 model and will perform the query based on that, and the response is also going to come based on the GPT-4 model. So let's go to our scenario number 7 now. In 7, what we are saying, like instead of getting a response in one go, we want to get the streaming response just like ChatGPT. So let's go to scenario number 7. So in this case, you just have to modify one parameter over here, and which is going to be this one. So you can see like we are loading the document, creating the indexes, and after that, like here, you just have to pass streaming equal to true. As soon as you put this particular thing streaming equal to true, it's going to respond in a streaming fashion, just like what we get from ChatGPT. Let's go to scenario number 8 now. And in this scenario number 8, what we are saying, we do not want to use a default response mode, but we want to change it. And for that, you can go here in this method, and while defining your query engine, you can pass this particular parameter response mode, and here you can pass whatever response you want to achieve. Earlier actually we were using this query engine only to get a response in the streaming fashion, but here we are going to change the mode, and instead of going with the default one, we can pass a different kind of response mode over here. For this particular demo, we are going to use the tree summarize. So let's go to scenario number 9 now, and here what we are saying, okay, we want a chatbot functionality. Earlier actually we were just querying it, you were just putting a query and were able to get a response, but you were not able to perform the chat. So if you have like any follow-up question, you probably have to just pass it over here and run it like again and again. But in chatbot functionality, you can pass a query, get a response, and then you can pass another query on top of it. And that's how like chat functionality works. So to replicate that, instead of using the as query engine, we can use another engine, and which is going to be as chat engine. And then actually once your query engine has been created, then you can, instead of calling query, you can just call chat. And then you can pass multiple queries over here. So the first question what we are asking is same like what we have been asking earlier. And then based on the response, we are asking another question. This is how you can modify your application and convert it into chatbot instead of Q&A. Let's go to our last scenario. In this particular scenario, we do not want to use the OpenAI model, and we want to use some open source model. So how can we do that? For this demo, actually, we are going to use Ollama. To get started on Ollama, you can visit this particular website. This is an official website of Ollama, and then you can go to this GitHub link over here. So the first thing what you need to do is install Ollama on your local, and you can download it based on your system. So I have Windows, so I have downloaded it from here. And once you download it, you can just install it as a normal software because it comes with the exe for Windows. So you can just install it in few steps. So once your software is installed, we have to run that. Now the Ollama comes with a different models altogether. So you can see that here is the list of all the models which comes under Ollama. So before running your Python code, you have to run the specific model. So in this case, I am using Mistral. I'm going to use this Mistral model to perform our query. As soon as Ollama gets installed, you can just search for Ollama over here and you can just start it. Once you start it, you will see, okay, Ollama icon over here. So just make sure this Ollama is running on your local before actually you try to run your code. One more thing that you need to do, so we cannot just go ahead and run this code now. You have to open a terminal and then you have to run a model. So as we have seen in the GitHub repo, we have to run this particular command if you want to use this Mistral model. So similarly, what I have done over here, before I execute this code, I have to run this particular model, which is going to be Ollama run Mistral, because I'm going to use this Mistral model in my application. Once you are done with Ollama setup on your local, you can just try this simple demo code, which would let you know whether the Ollama has been set up perfectly as of now, whether you are able to, get a response out of it before actually using it to query your documents. So here actually I am just importing Ollama from LlamaIndex LLM and then passing this particular model, which I'm using Mistral. Then I'm just using llm.complete and I'm passing a specific prompt. And here I will just try to print the response what I get from Ollama. So let me try to run this. And you can see like I have got a response. It just tells, look, Ollama setup has been done perfectly. The server is up and running. We can go to our main application now. So I will go to my main application, and here actually we will try to customize LLM model altogether. You can see this Ollama is coming from LlamaIndex. Under LLMs, we do have this Ollama. Earlier actually we were using this OpenAI. Now we are using Ollama. And with that we are just importing Ollama. Once you have imported Ollama, you can pass the model over here, which is going to be Mistral, and then the request timeout. What I have seen in the documentation, the request timeout window is quite less, like 30 seconds or 60 seconds. But when I'm using those particular parameters with my document, I'm getting a timeout error. So I have increased this to 3000. And one more thing what I wanted to highlight, when we are using this open source model on our local machine, it's taking a lot of time to provide a response. You can play around with the request timeout parameter, and probably like if you have a high configuration machine, then you would be able to get a response quickly. So this is how actually you can set up the Ollama model. So here I am just changing the default LLM model to Ollama, because now actually we are using open source. So we need something to convert this text into embedding also. And for that, I'm going to use the Hugging Face model, and that's why this particular dependency needs to be installed, which is going to be pip install LlamaIndex embedding Hugging Face. And once you have this particular package installed, then you can use this resolve embed model, and you can pass this particular model for embedding. So this particular model is coming from LlamaIndex core.embedding. You can use this particular method over here and then pass this Hugging Face model, which should help you to convert your text into embedding. Now, because we are using the setting parameters to set up our LLM and embed model, so it is going to replace the default LLM models, and it is going to use this particular LLM and embedding because we have defined it as a global parameter. So rest of the steps are going to be same. So now let me try to run all this program one by one, and we can compare the output from all these scenarios. So let me try to run this main.py, and the scenario 1 is our basic scenario, basic LlamaIndex scenario. So we have got a response from this one. We were chunking the response. So we have got this particular response from scenario 2. In scenario 3, we were persisting the index. So we have got response from this. In scenario 4, we were using the Chroma DB. So we have got response like this. In scenario 5, we were retrieving more context of it by manipulating the similarity top K. We have got a response like this. In scenario 6, we were using the GPT-4 model. So we have got a response like this. In scenario 7, we want to get a streaming response. So in scenario 8, we were using the different response mode, which was going to be tree summarize. So we have got a response like this. In scenario 9, we wanted to use a chatbot functionality. So yeah, the first response was this, and then we were asking additional question on top of it. So we have got a response like this. So in scenario 10, the request timeout, I have increased it to 3000 seconds, considering like I was getting timeout error with the shorter window. So this scenario 10 is going to take some time to print a response. So let's wait for that. So it took some time, but we have finally got a response from scenario 10 as well. And you can see this response we have got from Ollama, and this response you can compare with other scenarios as well. One more thing what I wanted to highlight here, like in this code, you could see like I haven't defined the OpenAI API key anywhere in the code, but still our program is running. And this is possible because already defined the OpenAI API key in my environment variable. So even though like if you're not defining it over here, it will try to go and check in your environment variable whether the key has been defined or not. So I will just show you in the environment variable, and here you can see like I have defined OpenAI API key, and then this key is being used to call like all the default OpenAI models while running the code for these different scenarios, except the last one where we are using the Ollama. That's all for this video. Thank you for watching.